All right, we're in section 4.4 where we are going to prove triangles are congruent by SAS, which is side angle side, and HL, which is hypotenuse leg. So the first thing we're going to look at is we're going to look at talking about right triangle. Any right triangle that we have has basically three main components. One, where the right angle is located. Second is talking about the legs of a right triangle. Those are the two side lengths that are adjacent to the right angle that actually touch the right angle. And the hypotenuse is the side length that is always opposite of that right angle. Okay. Why is that important? Well, we have a theorem that is going to allow us to determine if two triangles are congruent, and it states that if the hypotenuse and a leg of a right triangle are congruent, and it says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. So all you have to show is that the hypotenuses are congruent, which is here and here, which in this case is uh, BC and EF, and one of the legs, which in this case is A, B, and DE, and it's a right triangle, we can say that that triangle is in fact congruent. Now, when they are not right triangles, we can still use two sides and an angle to help us determine they're congruent, but in this case, it is only being used by angle side congruency, where the two congruent sides have to share that congruent angle. So if you look here, AB is congruent to XY and BC is congruent to YZ. And if you notice that those two congruent sides also share the congruent angle, which is B and Y respectively. Okay, and that's the only way you can determine something is congruent using side angle side when it's not a right angle. Being able to say like, oh, this works out because the two side measurements are congruent, and then the angles that are touching those two congruent sides or those two corresponding sides works out. It couldn't be any other angle that would work for that postulate. All right, so here we have a diagram to our right. We are asking, all right, it says that given that Kn is congruent to Mn, I'm just going to write that in. So Kn and Mn, I'm going to write that in because it was given, and Jn and Ln are congruent. They are asking us to prove that triangle JKN is congruent to triangle LMN. So we have two given statements. So those two given statements are the two statements that are given. We can say that KN is congruent to MN. And we can also say in statement 3 that JN is congruent to LN. So those are the two given statements up above. We have to fill in statements and reasonings 2 and 4. So for the most part, you can't prove that J, K, and L, M are congruent, so we have to go probably and use an angle. So the question is, since point N is the intersection of line segment JM and line segment KL, we can make the determination that angle 1 is congruent to angle 2 because angles 1 and 2 are both vertical angles. And vertical angles are equal to each other. So we can say here and here. And now we have two sets of congruent sides. And between those two sets of congruent sides, we have a congruent angle. So now I can go about and say that triangle JKN is congruent to triangle LMN, and that is because of side angle side congruency. Okay. I look here and it says in the diagram ABCD is a rectangle. So because they're telling us it's a rectangle, it has all the characteristics that a rectangle has. It has four right angles. It has uh, two sets of parallel sides, and the opposite sides are congruent. So looking here, it says that what can you conclude about triangles A, B, C right here, and triangles C, D, A. So if you look at the statement below the diagram, it says by the right angles congruency theorem, we could say that angle B is congruent to angle D. So they're both got right angles on there. That makes sense. Here it says the opposite sides of a rectangle are congruent because that's by the definition of what a rectangle is. So we could say that AB is congruent to CD and BC is congruent to DA. So we have two sets of congruent sides. We have one set of congruent angles that are in between that. And we can then say that triangle ABC is congruent to triangle CDA because of the side angle side congruency postulate. You could say, you know, by HL, but if you wanted to use HL, you had to have said that um, line segment AC is congruent to line segment AC to the reflexive property, and then go about, and then actually you could have said side, side, side if need be, but um, it had to have had one hypotenuse and one leg in order for it to be hypotenuse leg theorem. But we used side angle side because of the right angles that were given to us as well. And that is being able to prove triangles congruent by side angle side and hypotenuse leg theorems. I hope this helps. Till next time.